Happy Halloween, everybody. Welcome to another Unity workshop here from Mon River Games. For those of you who don't know me, I'm Joshua Robinson. I'm an adjunct with WVU. I teach the introduction to game engine applications, aka Unity. Uh, I'll be teaching that again in the spring. I see we've had a good many people sign up. I think we've got 10 enrolled now, so that's awesome. Um, and if the beginner course goes well, I've got materials prepared for an intermediate course that we're hoping to get offered in the fall of next year. So look out for that. So tonight we are going to look at Unity's visual scripting system. And I'll admit that this is not something that I have used a whole lot. Um, so I actually kind of learned a little bit about it so that I could present it to you tonight. The It's very similar to the way that Unreal does their blueprint system. So if you've used that, a lot of this will look very familiar. Um, I don't know enough about the back end of it to say, oh, but Unity implements it, differently this way, and it doesn't compile to native code or any like I don't know any of the real nitty-gritty details. Um, so the first thing I would invite you to do is take a look at the links that I posted in the chat to Unity's Learn system. Their website has some tutorials on they've got an introduction to visual scripting, which I don't know why it says this is 2 hours and 30 minutes. I think I blew through it in about 20 uh, minutes. But I was really just looking for the high level details. But this is a really good introduction. It kind of introduces you to all the concepts, what it means to create these nodes, how to connect them, things like that. I'm going to go through an example pretty quickly, so I might not cover in detail all the super beginner stuff. So this link would be a good place to go. And if you like what you see and you're interested in learning more, Unity has another tutorial um, which is appropriate for Halloween. Clive the Cat's visual crypting, haha, which apparently is a Sokoban type of game. Which, if you don't know Sokoban, that's where you have like blocks to push around, and you have to get the blocks into a certain pattern or onto targets. Um, I have not gone through this yet. It looks really interesting, so I probably will at some point. But I wanted to go ahead and bring it to your attention because it looks like something that would be fun and a good way to go forward with more visual scripting. All right, all of that out of the way, let's dive into our Unity project. So we're going to go back to our familiar horse pen here. I have named our horse character. Meet Adelaide. Adelaide is here to do some walking around. Now I have taken this from our previous examples, so I still have the tile set up, the collision on the tile maps and the collision on Adelaide. Um, the one thing that I have taken off is the script. So I no longer have the C sharp controller script attached to our horse. What we're going to do instead is we're going to create a visual script that does exactly the same thing. So let's take a look. First of all, let's just refresh ourselves on the C sharp script. So it was pretty basic. We have a move speed that we can configure from the inspector. We grab our animator component. We assign that in the start method. In update, we get our movement input using the WASD keys. We check to see if we need to update the X and Y directions in the animator. If we're not moving, we play the idle animation. And if we are moving, we play the walk animation and change our position accordingly. And then this other method, this is just the method where we read our WASD keys and return a vector 2 that corresponds to what keys you're pressing down. So pretty simple. I mean, we're less than 100 lines of code, and that's with generous white space as well. So let's see how we can replicate that in Unity's visual scripting system. I'm going to pull up my notes as usual and make sure that I don't forget too much. But we do have a lot of ground to cover, so I probably will forget some things. Fair warning. Uh, so the first thing we need to do to get a visual script going on our character is we need to, having selected her in the hierarchy over here, we're going to do add component, and we are going to add a script machine, which is kind of a weird name for the component, but this is what is going to enable us to write a visual script. So I click that, and it adds the script machine into the inspector here. You'll notice it also added another component for variables. And this variables component is where we're going to put our like our move speed input, which is one of the first things we're going to do. So now that I have my script machine, the first thing that I'm going to do is I'm going to come down here and I'm going to click new, and that's going to ask me to pick a place for the script. So I'm going to call this visual horse, and you can see that I've already done some work ahead of time. But for now, we're going to start with a blank slate here. And now that it's added my visual horse script to the component, I can give it a title. I'll call it horse controller, and giddy up. Why not? Um, so once we put in a title, and I don't know if it makes you put in a title, I always just have. Um, Once you've entered that information, we can click Edit Graph, and that'll bring us into the visual scripting editor. So I'm going to click that. And I've got this set up to take up the full screen. You can actually dock this in the Unity editor if you want to. Um, I wouldn't recommend it because you kind of need a lot of screen space to deal with this. So it's better working in full screen. Now, on the graph editor here, we've got two kind of main, um, sort of Dockers, and you can actually split these, and you can set them on either side of the screen. I'll do that while we talk about them, and then I'll probably stack them back up. So the blackboard is where you create variables. And these variables can be local to this particular visual script. They can also be what are called object variables, which means that they are on the object, that act kind of like the public variables or the serialized field variables that we use in C sharp. So I'm going to go ahead and make one of these because we need one for our movement speed, right? So I'm going to click on object to get into object variables, and I'm going to give it a name. So I'm going to call it move speed. I'm going to click the plus button. And when I do that, it's going to ask me for a data type. And our movement speed is a float. So I'm going to click the drop down and I'm going to pick float. And let's give it a default value of, let's say 3. So that's all I've needed to do to make that variable. And if I go to my Unity window, and I have to remember how to scale this so that it'll bring back. But you can see in the variables component here, it's added our move speed and our value to it. So from here, I can change that just like I could change the movement speed on the C sharp script. All right, let's go back to, well, what do we have to do here? I think I have to dock it. Sure. And then once I dock it, I can click full screen. Okay, now this will behave itself. The graph inspector, our other kind of Docker over here, this is what gives us information about what node we're currently working on. So if I click the start event here, then it'll give me some information about that start node. It's not real interesting because it's basically just an event. I think on update is the same thing. You'll notice that the visual scripting graph gives us the start and update events, just like when you create a new C# script. It goes ahead and puts the start and update methods in there for you. So that's kind of interesting that it gets you in, pretty much at the same spot. All right, let's move on and actually make something happen. So in my start event, if you remember from our code before, in the start event, we had to get a reference to our animator component. I'm going to make a graph variable, and I'm going to call this anim, just like I called it in the C# script. I'm going to click plus, and in the type, animator isn't, right here on the front. And you can search through these menus to find it. The other thing you can do is you can just start typing it in this little bar at the top. So I'm going to start typing animate, and look, there it is, animator. So I'm going to pick that, and the value starts as none. So on start, the first thing I need to do is I need to call our get component method. And we're going to do that just like we do in script. So I'm going to right click and I'm going to say add node. And that's how I make a new block on my graph. And I'm just going to search for get component. And when I do that, I'm going to get a list of things that match. Now you have to be careful here because I don't want component get component. I actually want game object get component. Um, so you kind of have to know what scope you want to make your method in. But when I click that, now it adds a node for my get component block. And this little green arrow, this is your execution flow. So when you connect these together, this means that execution is going to flow when the onStart event happens. It's going to go into this block and it's going to execute this block. So as long as the blocks are connected by this execution flow, that means that they're on kind of the path. And we'll show how you can kind of branch that path using ifs and things like that here soon. Now Unity will tell you, it'll kind of show you if something isn't on the execution path. So if I right click on this, it'll break the link. And if I deselect this block, you'll see that it dims out. And that's Unity's way of showing you like, hey, this isn't on the path anymore. So I'm going to just click and drag from here, and I'm going to connect this up. Now, this block takes two inputs. One is the game object that you want to get the component of. This is by default set to this, which means the object that this graph is a part of, and that's what we want to do. The other input is the type. What is the component type that I want to get? And so I'm going to go in here and I'm going to search for animator again. And I'm going to tap that. And now it has set our type to animator. Some inputs on blocks have these where you can just set the value in the block, but not all of them do. Some of them will actually make you connect this from another block. So now what I want to do is if I say I'm getting this animator, and from this component, I need to assign it to something. So I'm going to pull this little kind of page looking output here. Says this is going to be the return value of get component. So I'm going to just drag off of this into nothing. And when I release my mouse button, it's gonna prompt me for what node I want to put. And so I'm going to start typing the name of my variable, which is anim. And you see I get this option called set anim. So I want to set the value of this variable. So I'm going to click that. And now I have to connect my execution flow. And so what'll happen is we're going to call when start event happens, we're going to call get component to get our animator. We're going to save the value of that animator into our anim variable through the execution flow. And that's it. That's all we need to do in Start. Now, I know that was kind of a very long-winded explanation for that, but I hope I've covered, most of the kind of the introductory kind of stuff with it. Again, if you've used blueprints in Unreal, this is it. It works very, very similarly. So let's get into the update method. And I see it's already 20 after, so I'm probably going to have to go through this a lot faster. Um, but what I'm going to do here is the first thing that we did in our update method in script was we called this get move input method, because what we wanted to do is we wanted to put all of this where we read the input.get key, all of these if statements. We wanted to separate them from the update so that they weren't taking up space up here. We want to do the same thing here. So I'm going to click in the middle of nowhere just to deselect everything. I'm going to right click and I'm going to go to nesting and I'm going to pick subgraph. And what subgraph is going to do is this is going to create basically a new kind of a function, a new method within my graph. So if I double click on that, it takes me into a new graph with nothing in it with just my input and output here. And I should give this, I think we called this get move input, and I won't give it a summary. Whenever I want to go back to the main graph, I come up here to the top. You can see where it says get move input here, and then here's Adelaide, my object that my original graph is on. I click this and I go back into here. And I can double click on get move input um, to go back into this subgraph. Now, currently the input and the output to this, they don't do anything, right? They have like there's nothing coming in, there's nothing going out. So to get this kind of started, the first thing we're going to do is on our input, we're going to add a trigger input. And that is what's going to get our execution flow going. So I'm just going to call this invoke because I think that's the standard Unity name for that. And you can see that it adds my little green arrow along with invoke. I'm going to hide the label just so that it's the pretty green arrow like we're used to. On the output, I'm going to do the same thing. I'm going to have my trigger, and I'm going to call this exit, hide the label, so that we have our green arrow there. And then I also want to add a data output because if you remember from our method in C#, we wanted to return a vector2 that has the input data in it. So I'm going to click the plus button here, and I'm going to call this, I'm just going to call it move. And I'll go down here. I'm not going to hide the label on this one, and I'm going to give it a type. I'm going to give it a type of vector2. And it's giving me a warning. Okay, I don't know why it took my key away when I gave the type, but okay, so I typed the name back in and now it gives the warning is gone. So now I have my two outputs. I have my execution flow and I have my movement vector2. And so now what I'll do is I would proceed to go through and I would do these go through the get input. Now what I'm going to cheat a little bit, and I'm actually going to go out of full screen here, and I'm going to replace this script with one that I've already done. And I'm going to go back into here, and as you can see, we haven't gotten too much further than what we had before. So you can see I've got my inputs and outputs on get move input, except that when I double click on here, this is what get move input looks like. And I'll walk you through this. One thing that is kind of weird about this interface is that the scroll wheel doesn't zoom in and out like it does in the scene view. You actually have to hold the control button and scroll up and down to zoom in and out. So from our input, the first thing we do is we call get key, and we look for the W key. And what I do then is I run the output of that, which this returns a true or false based on whether the W key was pressed. And so I'm going to use this select block. And if the W key was pressed, then it's true. I'm going to select the value of one, which this is just a float literal. And you get those by right clicking, and you can just type in like float and get, float literal. And that lets you just give a number. So, this could be 4.69. And now that value is just there ready for you to use in your graph. So I have these float literals of 1 and 0. And what I'm going to do is if the W key was pressed, I'm going to take 1. If the W key wasn't pressed, I'm going to take 0. Then I'm going to check for the S key. If the S key was pressed, I'm going to take -1. If the S key was not pressed, I'm going to take 0. And you can drag off of an output more than once so that if I break these off, then you can see I can connect the 0 to here by dragging, and then I can click and I can drag again and I can connect it to a second block. And I'm going to take the outputs of both of these selects and I'm going to add them together. Okay, so this is kind of similar to what we were doing down here, where we were just adding -1 and 1 to the actual x and y values of the vector 2. We do it just slightly differently in visual scripting because it's a little bit more efficient to do it that way. So I'll just add, 1 or -1 if those keys were pressed. Otherwise, this will be a 0. And then I do the same thing with the A and D keys in this block. It's the pretty much the exact same thing. And then I take the outputs of those additions and I bring them into this block. This is a vector 2 create. And so what I'm going to do is I'm going to take this addition and I'm going to use that as the X. I'm going to take the other one. I'm going to use that as the Y. And what it's going to do is it's going to spit out a vector 2. And that's what I'm going to return in the output of my method. So when you click this overview button up here in the upper right, that kind of zooms you out to see the whole thing. So that's the entirety of our get move input method that we've adapted from the script. So it's a little bit different. So even if you kind of know some coding already, it does sometimes take a second to shift your mind into more of this sort of visual style of how you want to do things, like using this select block instead of directly manipulating the x and y values of the vector. So let's jump out here and let's actually do something with this. So the first thing I'm going to do is I'm going to connect my execution flow to that. In the script, when we get into the update block, the first thing that we do with the return value of this method is we normalize it. So let's go back into here and I'm going to drag off of our move output. And I'm going to go into, so you see there's this little arrow here. So vector 2 is the type of data that I've got. And so if I click on this, this is going to give me all of the kind of methods that I can call on a vector 2 type. So I'm gonna go to get normalized. And basically what that's going to do is that's going to return the normalized version of that vector, which if you recall, a normalized vector is one that has a magnitude of 1. So for example, if I was pressing both up and right, from get move input, those would each have a value of 1. So the length of my vector would actually be like 1.4. Okay, but I only want my magnitude to be 1. So I'm going to call get normalized on that to kind of get my magnitude where I want it. Go back to my script here. So the first thing that we do is this if statement, and we're going to check our move input against the vector 2 of 0. So what I'm going to do is I'm going to right click, I'm going to add node, and I'm going to search for vector2 dot 0. And so that's going to let me pick this get 0. And so that's going to return my 0 vector of 0, 0 for my vector 2. Now what I want to do is I want to compare these. And what I'm looking for is I'm looking to see if they are not equal. So I'm going to right click, add node, and I'm going to search for not equal. And I'm going to find that block and click on it. And what I'm going to do then is I'm going to pull these both into here. And so what I'm saying is I'm going to compare these two, and then I'm going to get the value. This is going to be a Boolean. This is going to be a true false. And so what I have to do with that is I have to run it into an if statement. So I'm going to get my if. So now I can pull my execution flow over. This is the input to my if statement. So I'm going to connect it to the not equal. So if these are not equal, that's going to return true. And if they are equal, if not equal is false, it's going to return false. So I will take the true, and because that's what I'm looking for in here. And what I'm going to do is I need to set the float, this x direction float, to the x. I'm going to set these to the x and y values of my movement input. So what I'm going to do is I'm going to right click, add node. I'm going to do animator, and I'm going to click on the animator to go into here. And this is going to give me what, all my methods that I can take. And let me just keep typing. Set. There we go. So I've got animator.set, and I'm going to do set float. And it gives me it tells me what inputs I'm going to need here. I'm going to need the name, and I'm going to need the value. So I'm going to click that. And this is going to happen if this is not equal. Now, it needs to know what object it's going to execute this on. So I'm going to go over here to my Blackboard, and I'm already in my graph variables. And if I pull this, there's two little lines over here on the side of this. And if I just click and drag this into the graph, that's going to give me a get on that variable. So it's going to get the value of that variable. And I'm just going to pull that into here. So I'm going to say this is the animator that we're going to be working on. And I'm going to set x direction. And I want to set it to the x value of the vector off of normalized. So I'm going to pull off of this. It's going to give me vector 2, and I'm going to get the x. Just like that. And so now I'm going to be setting the x value of my normalized vector to the x direction on the animator. So now I can click this, and I can hit Control C, Control V, just like everything else, to copy and paste this block, pull my execution flow in. I'm going to rename this to, click in there, buddy, to Y direction. I'm going to pull my animator over into here too. And then I'm going to pull this off. I'm going to go to vector 2. I'm going to get Y, and I'm going to pull the Y value into here. And so now I have set the X and Y direction values on my animator based on this if statement. So as you can see, I mean, if you're somebody who's used to coding, you think, man, I could have typed that if statement in like 30 seconds. And it does take a little bit longer to do this visual scripting, but it is kind of neat the way that it lets you conceptualize things. Although it does take a little bit more time, especially when I'm trying to walk you through and explain it. Now, since it's 7:35 and I don't want to go on forever, what I'm going to do is I'm actually going to take my completed script and I'm going to pull it over into here, and we'll take a look at it, starting from where we left off. So the next thing that we check in our script here is we check to see if the magnitude of our input is less than 0.1, because that indicates that we're idling. So from my normalized node here, I can also call get magnitude, just like I did get x and get y. Call a less than block to check it against a value of 0.1, and that'll return a true or false. and I'll run that into another if statement. Now you'll notice that I pulled the execution flow from the false here. So if this if statement is false, I'm not going to do any of this stuff. So I just pull that execution flow on over into the next if statement. And I can connect both that output and that output to the same input here. So that's where the execution is going to go. So if this if statement is true, I'm going to call my animator again. I'm going to set the state name to idle, and then that's it. That's all we do. That's the end of the update method, right? Because the next thing that we have is an else. So if this is true, then nothing past this point gets executed. And you can see that where our kind of execution ends here. Now, if this is false, we're going to play the walk animation, and we're also going to calculate uh, how much distance we should move. So I'm going to come all the way back over here to our normalized, and I'm going to walk you through the calculation here. This is where we're getting our variable of our move speed, and we do this just the same way that we did with the animator. We just go and select object from the blackboard, and we can pull this out onto here, and it'll give us that get block. I'm going to get rid of that. So we're going to multiply our movement speed by the normalized value of our vector. We can also call get delta time by just, again, right-clicking and searching for delta time. We can pull this value out. We're going to multiply that again. If there's a block that lets you multiply more than two things, I haven't found it yet. It's kind of annoying to have to stack them like this, but that's how it's got to be done, I guess. And so what I'm going to end up with is I'm going to end up with a vector 2. Now, before we called get x, get y, and that's perfectly fine. But if you know that you want like more things out of your vector, you can call this expose block, and that will give you all of the values that you can get off of that. Now you see I've unchecked static here, and I'll go down to this one because if I check static, this is going to give me a whole bunch of extra stuff like the up vector, the forward vector, and all of those. And I don't want those. So I'm just going to uncheck that. So I'm going to expose the values of my vector 2 that I've calculated for my move distance. I'm also going to go get the position from our transform. I'm going to expose the vector 3 that we get there. I'm going to add the x values. I'm going to add the y values. And I'm going to just pull the z from the transform because I'm not going to change it because we're in 2D. Then I'm going to take those three values and I'm going to create a vector 3. And then I'm going to set that vector 3 back to the transform, just like we do in code. And so that is our update method, which, as you can see from the overview, it gets pretty big, but it does kind of give you that very nice sort of step-by-step flow through what you're doing. And just to prove that that this all works, we'll go back into here. I'll save the scene real quick, and I'll hit play. And then I can hit my WASD keys, and I can walk around my horse pen with our lovely horse Adelaide, having a nice time.